Good morning everyone. Today we are going to be looking at bearings, and if you take away anything today you should take away the three rules that are governing bearings. That is that they're always measured from north, they're always measured clockwise, and they are always given in three figures. The other thing that you should take away is the significance of the word from. And the significance of the word from means starting from. So what is the bearing of B from A? You're going to start at A and go to B. So let's look at an example and just really clarify what's going on here. What is the bearing of B from A? Okay, so you are going to be starting at A, which is this point here. Maybe I'll move the circle over. It's technically that point there. Okay, and I've drawn in the north line, so that's the first condition. We then measure clockwise to the line we've got to travel to get from A to B, and then we have to work out how much that is. So here we've got 38 degrees. Is my answer just going to be 38 degrees? No, it isn't. Why? Because if we look back at the original question, they're always given in three figures. So it's actually 0.38 degrees. So if you have single digits or double digits, we fill the rest of the space in with zeros. All right. Then how about going back from B to A? So we start at B here. We draw in our north line and we're going to go clockwise. And we need to find out what that angle is. Well, if I draw in a dotted line here, this is going to be 180. Why? Because angles on a straight line add up to 180. And we've not covered it yet on the channel, but there are videos on this elsewhere. You have a set of parallel lines here with these two north lines, and you've got an alternate angle there. Alternate angles are equal, which means that this angle here is going to be 38 degrees as well. 180 plus 38 is going to be A from B. If I put this in on my calculator, 180 plus 38, 218. Okay, next example. So we've got Q and P this time. What is the bearing of Q from P? So we are starting at P because it tells us from P. So I'm just going to get a mark here from P. We're going to measure from north, so we have to draw in the north line. If it's not there, you've got to draw it in. You're going to go clockwise, and then what's the angle going to be? Well, the angle will be 121 degrees because it's marked on the question. And that is our answer here, 121. Now what about P from Q? So we've got to start at Q because it tells us from Q. There's our starting point. We draw in our north line. We measure clockwise. And that's the angle we need to find out what Q is. So what we really need to help us with that is to find out what this angle is here. Now if I get my highlighter pen again, I'm going to draw in two parallel lines, which are the north lines, and an intersecting line between. And this generates an allied angle. Allied angles add up to 180 degrees, which means this angle here is going to be 180 subtract 121, which I believe is 59. And if that's 59 degrees, then angles around the point will add up to 360, giving us that this angle at Q being 360 minus 59, or 301 degrees. So notice we didn't have to use the third rule of bearings there, that all bearings are given in three figures, because the numbers that we've got, 121 and 301, are all three figures already. But say I wanted 80, it's not 80, it's 080. Okay, so be very aware of that. The three-figure rule means that you're putting double digits or single digits into three figures. Let's move on and look at a more difficult question. Work out the bearing of A, y from x. Y from x means we're starting from x. Here. We've got our north line. We're going clockwise. Oh look, that's kindly marked in for us already. 130 degrees. I'm going to move this, if I can, grouping. It just makes life a little bit more easy when it comes to actually writing in the answers. X from Y. Okay, so again, using the principle of allied angles from parallel lines, I can see that I've got two parallel lines here, the north, and this is an intersecting line between them, meaning that this angle here is going to be 50 degrees. Why is it 50? Because 50 and 130 summed together will make 180. Now we can use our rule of bearings from Y. Always measure clockwise, always measure from north. It's going to be that angle there. 360 minus 50. 310. Okay, so that is 310. Z from Y. So we're starting at Y and going to Z. North line is already drawn in. I do this in blue, I think. Clockwise, bearing there. Oh look, that's marked in. It's 70 degrees. Except we're going to write 070 degrees because bearings are always given in three figures. Next, Y from Z. Okay, so if I take a line, I'm going to draw a south line in here. Just move it over slightly so that it looks a bit better. That fixed it. There we go. I'm going to change the properties of this as well. So I want a dotted line. There we go. Good. So if I close that up, I want to go back to my highlighter pen, and I'm going to use blue, I think, this time. So if I highlight the two parallel lines, which are the north lines, and then I've got an intersecting line between them, which is that one. So can you see you've got a Z angle here, which means the angle at the bottom between south and this line will also be 70 degrees. It now becomes very trivial to work out the bearing of y from z. We start at z, you put my cross in, we draw the north line which is already there, we measure around clockwise, there we go, and we work that out now. Well, angles on a straight line are 180, so that is 180 there. 180 plus 70 is 250. Degrees. And that's our answer, y from z. Lastly, x from z. Now this is a bit more tricky. You notice I've got a very faint dotted line connecting x and z together. From means we're starting from z. Okay, change colour again. Let's go for purple this time. We've got the north line drawn in, and we need to go round to this dotted line that's above the YZ line. So I'm going to draw that in with a purple pen, and you can see that that's that bearing there. Okay, so again it goes around 180 degrees, but we don't know what this angle is at the bottom. The correct way of dealing with this is not to use the 180 plus an angle result. We have got to use the fact that it's given us 100 degrees here between the dotted line and the north, but counterclockwise. So that 100 there, it has to be subtracted from 360, because angles around a point add up to 360, and that will give us our final answer. 360 minus 100 is 260 degrees. Okay. So there's a lot of different techniques going on there, but you've got to know parallel lines, and I will do a video on that soon. Maybe my next one actually preparing parallel lines. You've got to know angles around a point add up to 360. You've got to know angles on a straight line add up to 180. You've got to be able to add angles to 180, and you've got to be able to subtract angles from 360. If you can do all of those things, then this is really straightforward. A couple more questions. Where is Potter's bar? If it's on a bearing of 80 degrees from Hemel, that's naughty of me, I will add in what it should say, a bearing of 080 degrees from Hemel, and on a bearing of 120 degrees from Milton Keynes. So, this one is asking you to use the tools in your possession, and you should be aware of what this is. This is a protractor. Protractors can be used to measure angles. So we're not just going to measure an angle, we're going to construct an angle. If I can get this thing to turn around. There we go. So we want it vertical, and I'm going to put the centre of it over the cross on Milton Keynes. Okay. Now we're going to read the outside scale, because the outside scale is the one that's getting bigger as we go clockwise from Milton Keynes. And remember the rule, clockwise is what you have to do for bearings. It's the second rule. So there are two ways that I can do this. The first way is I can just draw a line at 120 degrees. Like this, Okay, and that's probably the best way on a computer screen to represent what bearing is going on. What you're actually going to do, given an exam paper or a question, you will put a little mark at 120. There we go. You can see the dot there, and I'm then going to move the protractor and use your ruler to draw a line from Milton Keynes through the dot, and it's exactly the same thing in principle. Next we're going to Hemel Hempstead. We're going to put the protractor on the cross. We're going to put a little dot at 80 degrees. This time I'm going to use a different colour. 80 degrees. That's not quite right. Little dot can get erased. Nope. Okay, it doesn't seem to want to erase my dots. Up now. Nope. Let me move the protractor slightly. Okay. We'll get rid of it. Persistence. There we go. That's the way we'll do it. Protractor is on the cross in the centre. I'm then going to use my pen, different colour, add 80. It's not quite right. Going to move the dot very slightly. There we go. That's perfect. Okay, we can see that that's at 80 degrees. Move the protractor. In fact, I can switch this off now. Oh, no, not get two of them. Switch it off and use my ruler to draw a line through the dot, and the point of intersection of those two lines, this is Potter's Bar. Okay. Good, that's another type of question that might come up with bearings. Back bearings. Back bearing is the return bearing you need to travel to get where you started. So typically you either add or subtract 180 degrees to your answer to calculate the back bearing, depending on whether your forward bearing is greater than or less than 180 degrees. So I'm going to give you a couple of examples here. This question was the question we just did here. So we worked out that the bearing of B from A was 038 and A from B was 218. So I'm going to put those on. Moment. This was 038 and this was 218. Notice that if I add 180 degrees to 038, I will get 218. So you have literally just, there's the forward bearing, 038. To get the back bearing, you're adding that 180 plus 38. Next we're looking at Q and P. So what is the bearing of Q from P? So we start at P, we go backwards or clockwise to generate this, and that will be 360 minus 60, which is 300. So I'm not going to add 180 degrees to 300 because that would be 480. I'm going to subtract 180 degrees and that will give me an answer here of 120. So that's a really fast way of getting the back bearing. So I'm saying that P from Q, this one here, is 120 degrees. And yes, that's correct. Why? Well, if I use my highlighter pen, and I use yellow this time, two parallel lines, an intersecting line between them, you've got allied angles there. 120 plus 60 will make 180. Okay, so that's a really useful trick to know to generate the back bearing. You either add 180 or you subtract 180 depending on what the original bearing actually is. Lastly, you may see a question where they want you to measure distances. So let's do this and go through it. The picture below shows two ports, R and S. Lifeboat's distress signal can be seen on a bearing of 100 degrees from R and a bearing of 200 degrees from S. Mark the position of the lifeboat. So what's missing in this question? Well, we've got the R and the S, thankfully, but we don't have north lines. So that is something we are going to have to draw in ourselves. 1 and 2. On an exam, you're going to need to have to do that with a ruler and pencil. North and north. Right, so we've got no line between R and S. We have to construct our bearings. So that means we're going to need this thing again, protractor. And I see if I can tilt it around myself this time. Here we go. There we go, that's better. So notice if I put this over R, the 0 line is directly over the north. 100 degrees. I'm going to move this over so you can see the question. There we go. 100 degrees from R. So back to a pen. 100 degrees is here. You can put a dot by 100. Okay, you might not be able to see that, but let's show you. It's there. Okay. If I move the protractor, I can draw a line between R and that dot as such. I'm going to make it long because it doesn't tell us how far along this line the lifeboat is. 200 degrees from S. So I'm going to move the protractor back over to S. Now you can see going along the outside scale of the protractor that the maximum it goes up to is 180 degrees. But we're looking for 200, meaning we are going to have to generate a line at 180 degrees. So this is like a construction line. I'm going to make it dotted because it makes sense for it to be dotted because it's not really there. Okay. There's our dotted south line, and we should know there's the proof that angles on a straight line equals 180 degrees. Okay, so I can draw that in. That is 180. We're looking for 200. So 180 plus 20 is 200. That means that 20 is now the important figure we're looking for. I'm going to rotate my protractor. Okay. And it's facing the opposite way, but we can see going around the outside edge that you've got 20 there at the bottom. So if I use a different colour, let's go with green, put a dot there at 20, that's good enough. Move my protractor. I can now create a line going through the green dot and that the point of intersection is the lifeboat. So I can put that in. Whoop, what's going on here? There we go. Let's move this now. Delete the protractor. I need an arrow. There we go. That's our lifeboat. So, how far away is it from each port if 1 cm is approximately 2 kilometers? So that's telling us we now need to measure these lines, R to the lifeboat, RL, and SL. So we need another piece of information, another tool, which is a ruler. Okay, now I am going to rotate this ruler, if I can figure out how. That's enlarging it. How interesting. There we go. We're making progress there. Not quite right. I'll change this very slightly. This is very sensitive. I'm pretty sure that's the way of doing it. Hang on. Smart tools, come on. I think that's the best I can do on here, but you will have the dexterity when you're doing this by hand to see what's going on. Now, the distance RL, if I look very carefully there, and I will write this in, RL equals 10.9 cm, L being the lifeboat, and now we need to look at SL. So bear with me again whilst I rotate this. How close is that? That's miles out. Again, I think that's the best I can do. That is 4 point... No, it's 5. It's on the nose, 5 cm. So your examiner will want to see that you have measured the lines. So even if you don't get the answer right, that is helpful because it shows that you have measured them. Now we've got to try and work out how far away it is if 1 centimetre is approximately 2 kilometres. So there's a ratio going on here, and I will write this down. Okay, 1 cm equals 2 kilometres. Let's do SL first. 5 cm equals... Now you should automatically be able to jump to 10 kilometres. But how have I done that? I have multiplied 1 centimetre by 5. And 2 kilometres by 5. So you've applied a scale factor. Next, we're going to look at 10.9 centimetres. Now I can't do that off the top of my head, I'm going to have to use my calculator, but you should be able to see that you have multiplied here by 10.9. you're going to have to do the same on the opposite side, times by 10.9. Maybe I can do that in my head. 21.8 kilometres. I'll double check because I don't want to give you the wrong answer. But I'm pretty certain 10.9 times 2 is 21.8. It is. Good. So those are typical types of questions that you're going to come across in bearings. It's well worth knowing how to do all of that. In the item box below, you'll see some questions on this as well as my notes from this video. Please check them out and support me in this channel. I will see you again on the next one, which I think I'm going to do parallel lines next because that's important to understand what's going on here. Good. Leave you with it and see you again soon. Hi everyone. This is a friendly reminder to like, subscribe and hit the bell notification icon to stay tuned for future videos on this channel. I also welcome constructive comments in the box below, and you can gain access to any of my teaching resources through the link above. If you'd like to support me through donation, you can either go to paypal.me/JonathanKipping or patreon.com/JonathanKipping. Stay tuned and look forward to future videos.